What's going on, guys? Hitpause here. Welcome to the summary video for how to use the EQS environment query system that is experimental in 4.6.1. Again, I do not know if that is experimental in the 4.7 preview build yet, but it is experimental in 4.6.1. So basically what we got here is we got a bot that knows where to hide from us. And right now he's trying to pick the closest hiding spot to me. Okay. So he's trying to hide right around the corner, the one that's closest to me. Stay out of my view. Okay, he doesn't always stay totally out of view, which is good or bad, depending on what you want to do. Like if I ditch way over here, he'll want to hide like right there below me. Okay, he wants to hide right there. Remember, I'm tracing against the navigation, so he thinks this is a good hiding spot. And if I come over here, see him. I don't know if he can see me right here. He thinks those are good hiding spots, but they're... I think that it's a little weird when it gets to this point here. He's probably glitched out, but that's kind of the problem with the EQS system, not necessarily what we've done. We're just basically using it right out of the box. So if I play it again, don't get him to go up there. You can see he's working pretty good. He's ditching around. It's totally awesome. And if I come over here, he'll want to pick this closer point. Gets to behind this guy, and then he should want to come over to this one. But he might not be able to see that as the closest one. Yeah, he feels that he's also checking what's the closest to himself. Okay, so that's so he'll keep running around this until he's only, he runs it every little bit, and he's only running a check every half a second, so he's got a little small bit of delay in there, and that's to give him the old human error thing and stuff. So let's go through it really quick, as quick as I possibly can. He's got an AI controller. Basically, at the begin play, we run the behavior tree. This is the one we created. We tell it which blackboard do we use, and we tell him that he can see us in the beginning. Okay, so go ahead and try to get a good hiding spot right in the beginning. So we get the blackboard here from ourselves, and we set this key here. We have the behavior tree, also our character, just to be sure you guys know. Do I have him up here? No, I don't. Runaway character here. In his defaults, I am the only thing I cared about here was that he was using my AI controller runaway here, so this is the kind that's going to try to hide from you. Okay, obviously this in the real game would be much more actually, it doesn't have to be. It could just be something you're trying to chase down and catch, a little runaway gnome or something that stole your shit. You can see we've got the dots here for the environment query, and the way to get that to show up, if you haven't watched the video, is you need to create an EQS testing pawn. Now this is just a specific type. If you go to blueprints and you just type EQS, it's basically one of the only things. I've already created these, but you create a testing pawn, and then when you have the testing when the testing pawn is selected, you tell it which environment query you want to run here. Okay, so this is the one that I've made, new environment query. So if I rename that, it'll rename over here too, because that's the only one that it's using. So the environment query here, you can create that by creating a miscellaneous environment query. Now, I forgot to mention that you do have to, in fact, go to editor preferences, go to experimental, and at the very bottom you have to check off environment querying system. Otherwise it won't show up anywhere. You can't do anything with it. And then just set as default here, so it saves it, and everything will immediately pop up. You don't need to restart the editor or anything like that. Okay. We have our environment query that we have created here. I'll go through what we've done here in just a second. Here is the behavior tree. We are running I'll just do this in order. We're using a sequence here, so it just goes through them one after the other based on whether or not it can. Okay, with these blackboard decorators here. The service is basically quite simple. On start, we just store the store variables for the controller and the character. Once we're done that, we open up a gate for tick to go through. We basically check the distance between the AI character and the player character. If it's within 2,000 units, okay, so if it's greater than 2,000 units, we basically fail out and we set the Blackboard key can see player to false. If it's not, it means he's close enough. We run a trace, okay, line trace for objects. We're checking against static, dynamic, and pawn, and we're doing it from the AI character's head, which is just adding Z24 here, to the player character's head, which is the same thing, adding 24 here, and we go start to end. Again, object types are here. We want to ignore ourselves, and because the AI controller is the one that is initiating all of this stuff, it does self here is not the character, so the character itself does have the potential to block this trace, block his own trace basically. So we just bring in this variable. You can just go like this and say make array. Okay, boom. So because it expects an array, so you just add one item to an array, just kind of trick it right here. Throw that in the actors to ignore so that the trace doesn't hit the actual character itself. If we hit anything, which for the most part on this map will be true 100% of the time, we're going to run a check now, and the check is very simple. We break the hit result just to get all of the information of what we traced against. We check the hit actor, does it equal the player character? If it did, we can see him, true. If it didn't, we cannot see him, false. That's all this check does. First filters by distance, then filters by whether or not it's got a line of sight, and returns the Blackboard value, Blackboard key there. Okay, this Blackboard key is set to can see player here. Okay, this will not be here if you forget to set the key to visible. Okay, to create a new variable here for the Blackboard key, just let's make it whatever it is. Here you can create them here, just type in the word black and it's Blackboard key selector. It's the only thing. If I do test ests here, as soon as I make that visible and I come up here and I go back to my service, you can see test ests appears. Okay, and I can tell it, okay, well, what key am I worrying about here? The Blackboard itself has 3 keys. One of them is actually not being used. This self actor here, to be honest with you, actually I forgot that this just keeps getting injected into my Blackboards all over the place. You can save it and then close the editor. Like, you can delete this, save it, close the editor, come back, and it'll be back. It's just like something that they add. I don't know why. It may be a bug, but it doesn't seem to hurt anything. So you don't need this, but I can almost guarantee that it'll add it for you anyway at some point. But basically we have move to point, which is a vector, can see player, which is a boolean. That's all we care about. Okay, so that's the service. Again, right here, just checks distance, then line trace, sets the key whether or not it's true. So we come here and we just say, okay, if can see player is set, which means it's true. If it's false, it officially calls it not set. We run this EQS query. Now the EQS query needs to know which value on our Blackboard are we actually like scoring and setting here. And in this case, we want the move to point vector value to be the one that we're setting. Also, don't forget to tell it which query template to actually use. Okay, so in this case I only got the one, so I'm using that one. There are query parameters which I've never actually used. I'm really new to this whole thing, but just make sure that you set the template here, because this does become available once you go tasks. It is here automatically as soon as you activate the experimental feature. Okay, and then the next thing we do is we do a move to, and the move to Blackboard key that it's moving to is move to point. Again, move to is a hard-coded system here that says move to. Okay, like that. It's automatic. I don't know. I don't really like it that much because it doesn't have any like stuff for failing or succeeding, and there's no. Like it seems it's been a little dangerous for me. I've actually had crashes because it like fails, and once it fails, then there's like no way out of it. So I tend to make my own tasks for this, but in this case, because everything's so simple, it's working fine. There's also move directly to, but that ignores navigation. So this will nav to the point that you give it to, which is a location. Again, move to point, which is a vector. And this is only going to run if move to point is set and we can see the player. So if we don't have a point and we can't see the player, we don't give a shit, we're not going to do anything. This is just a simple wait, just to basically get us sitting there doing squat, and it only does this if we cannot see the player. Okay, so that's the entire blackboard, that's the entire behavior tree, and the entire blackboard right here, these two here. We did create a context for the queries, because when we do the environment things here, we go distance to querier, distance to player, distance to, or trace from the player, distance to player, and you can see here that I have these contexts here, and those are here, and the way to create them is to just go env, and you pick this as your parent here, the environment query context blueprint base, and then you can name it whatever you want. And what you do is when it comes up, it's pretty much empty, so what you do is there is a provide single actor. This will be a list of 4 things. You can right click and say implement the function, so do that on provide single actor when it first comes up, and it will pop this open in your window in your graph. Okay, you can see the event graph is completely empty. And for player, we just tell it, okay, provide single actor, we're just going to return the player pawn. Okay, and then there's also one I did for yourself, and if you do that, you just return the querying actor. Now I don't believe that this one's actually necessary, because basically you can just say here to use querier, but and that should be the same thing as saying query from like the bot or from something like that. But I made one for the bot because what if something else wants to know what like the bot can't see? Like what if the bots can fight each other, right? So I need to know, you know, bot to bot, so that wouldn't, you know, you guys know what I'm talking about. There's, you know, sometimes you might need to be able to figure them out from a distance, or you know, from another thing, not from just me. Okay, so again, I'm using math path distance of 1500, so it's pretty far that it's checking. The density is reverse, it's opposite. This is actually should be called spacing. The higher the value, the less points that you get on the field. The lower the value, the more points you get, and if you set this way too low, you will crash and you will lag and everything will freak out unless you got a supercomputer. We do have path to context checked. Again, we're generating just around the querier here. The trace type is navigation. You can do this against geometry, but if you want them to use the nav mesh, tell it to navigation to be navigation here. And the filter is the recast filter. Use default area. I believe it'll actually still work if you set this to none, but I'm not going to test that. I put this in here anyway because that's actually what I'm using here. This is my recast. You can see it right here. That is actually the, you know, the thing here. If I set, you know, like the agent radius to be, you know, like 70 or something, you can see we got a much wider area right there. If I set it to like 10, it's really tight and close. It'll probably bang into it. 36 I believe is like the default or something like that. So the recast is what's actually controlling this area here. Okay, so back to the environment query. So the first one we do is we do distance to querier. So basically it's a distance to myself. I want to know which point is closest to me, which is me being the bot, because the bot's the one running this. So whichever one's closest to the bot, we use distance 3D. You could use distance 2D in this case, or like, you know, how high something is. Then we're going to say, okay, remember distance to myself, so it's the querier. We're only going to score, and we do a -1 here. That will turn this to prefer lesser. If I set this to a +1, he's going to prefer everything that's farthest away from him, and that is actually officially going to give him retard behavior. Okay, so he's going to constantly be running back and forth in front of you like an idiot. Then what we want to do is we want to trace and find out what the player cannot see. So we do a visibility line check. We do only blocking hits. Okay. That I believe this is where it actually says, I can't remember how to get it so to tell whether or not you can see something, which in this case we don't want. We want them to only go to the points that you can't see. And again, we're going from the EQS context player here, okay, which feeds in the player pawn to be the returned actor. So that's it's checking, it's basically centering the points based on my player for this particular check. Okay, as here you can see that the points are centered around this actual actor here. Okay, it's a grid around the actor, but in the case of this test, we want that centered on us, on a player character. Okay, again, that's why we set it the EQS context player right here. Again, score only and a value of 1. I don't remember what happens if it goes -1. It probably he's going to look for things that you can see, but that could be here or not. It's simple to test that. I don't want to go through a bunch of like experiments while I'm doing this. I'm just trying to get through it. And then we're also trying to prefer right now, we're trying to get him to pick the points that are closest to us. That's why he runs to the things that are closest to us. If I set this to a positive one, this isn't actually an experiment, I know this works. He's going to run to the farthest one away. You see that? So he's trying to get to the point that's like the farthest from me. And in some cases it's, you know, not within the radius, so he's trying to get over there and hide away from me over there. Okay, so you can see he's not trying to stay close to me. And if, you know, if there's no place for him to hide, you know, he doesn't know what to do. So you need logic for that. Okay, so he goes behind there. So that's how you can swap whether or not he wants to stay close or far away, just the positive or negative right here. Okay. I don't think there's anything else I missed. There's the blackboard, there's the AI controller, there's the service. Okay, that's just again checking for distance, then trace. And there's the character, and it's just the 3-player character is told to use this AI controller. There ain't nothing in the graph. Okay, I didn't do anything to it whatsoever. And that's it. That's all you need to know to get the EQS working. And again, the thing that threw me for a loop was I didn't know how to actually use it, and the way that you actually do use it. Did I close my behavior tree? I did. Is to tell the querier which value you want it to actually return, basically. And that's that right there. So if you wanted it to, you know, you could have it return actors, because you can query against actors as opposed to navigation or geometry and whatnot. But for the most part, I felt that, you know, points in the space, because, you know, you're looking for a spot, right? It seems to be the best way. So that's it. That's it. It works. It works great. It's very, very, very powerful, I think. Can be used for tons of stuff, for really awesome stuff. I don't know how to quite get it to work like on like a flying AI yet, but I do believe that it could be extended in that fashion to find out where a flying AI could see stuff. So it's totally cool. He's hiding. Yeah, you play tag. Come here, you little shitbacks. You bastard! I'm gonna get you. I'm gonna get you. Yeah, I got him. I got him. This looks weird. Like, I feel like I should be giggling, or he should be giggling while I'm chasing him. Like I'm ready to tickle him. So, yep. So like something like I said, like I mentioned this in another video. Like Boomer in Left 4 Dead has this kind of behavior. He'll run away and go to like the farthest hiding spot, like within a certain radius, and he'll wait there while he can't spit. As soon as he can puke on you, he'll come charging straight at you for the most part. So you could definitely do that. Like you could have him pop out, shoot at you. If he's got to reload, like while he's reloading, he could go and try to hide while he's reloading. That would be an awesome behavior. Something like you know, something like Alien Isolation, where the alien is kind of like after your ass and doesn't really have any fear. Really the only time that I would say that something like this would be in use on that kind of AI would be like when you flamethrower the thing. Then it tries to run away and hide. But for the most part, in that game, is completely different, right? He goes and basically rushes towards the closest vent that he can get to. So, yeah, see right here he doesn't know what to do. So the really complex geometry, I'm sure that if I put the environment query thing up here, that it would, now he kind of knows where to go. It's a little bit more. But yeah, it's not like that they can't get stuck in, you know, other types of stuff, because it is projecting like on the floor around me, and I think these points count as, you know, can't see it kind of thing. But you can get them to go back down, so I think you know, you need more logic in there than just this, I think, but it does work pretty good. Definitely works pretty good. He's going. So you go hide around that corner, you see. And he'll keep doing it till. You see, now he doesn't know what the hell to do. It's like I've caught him, basically. Yeah, so he thinks up there he can't see it because it's like it's not really totally properly like projecting to the nav mesh. I think there is a way to actually do that. You can see we get some points in here that are inside like this. So, thanks for watching. Hippo signing off.